All right, this is the walkthrough solution for review problem number 1, really a shear moment diagram problem. So we want to determine the shear moment diagram for this shaft. Again, it's just a statics problem, just to get you back into thinking equilibrium. All right, so first thing we want to do is we have to establish equilibrium. So that's going to mean a free body diagram. Okay, so there's my line that represents my shaft. At the left end, it's fixed in the vertical and horizontal. So it's going to have an AY and it's going to have an AX. And again, I'm assuming directions. BY, it's just like a hole for the shaft to pass through. See these over here, it's locked in, has a collar, keeps it from going left or right. On the right hand side, it doesn't have a collar, so it's just going to be a BY. And we're going to show 600 pounds. And we're going to show 300 pounds. And we'll show this 1,200 pounds, but I want it to really be, I want to make a resultant of 1,200 pounds per foot times 8 feet, and end up with 9,600 pounds. Because that's what I'm going to use to calculate my reactions. Okay, 9,600. Okay, so easy one first. I'm going to sum forces in the X equal to 0, so 0 equals AX. No surprises there. AX equals 0. Now I'm going to sum moments. Again, I'm going to pick a point to sum moments, and I can really do A or B. I'm going to need to know my moment arm distances. So this is 2 feet. This is going to be 8 over 2, which is 4, and 4, and this is 1. So I'm going to sum moments equal to 0. Counterclockwise is positive. All right, and I'm going to have 0 equals. I got 300 times 2, and again, this is going counterclockwise, so that means it's going to be positive. And then I have 9,600 times 4 feet, and again, this is going clockwise, so therefore it's going to be negative. And then I have BY times 8. It's going counterclockwise, so it's going to be positive. And then I have minus 600. Oops, I don't know if it's minus yet. I shouldn't have done that yet. Jumped the gun. So I'm going to say force 600 times 8 plus 1, and it's going clockwise, so therefore it is negative. Okay, so now I have 0 equals a positive 600 minus 38,400 plus BY times 8, and then minus 600 times 9, 5,400. And notice everything is in pound feet. Okay, so now I solve for BY, and I leave BY times 8 on the right hand side since it's already positive. Bring everything else as positive, negative, negative, and I'm going to bring it to the other side. I get a positive 43,200. And when I divide by 8, I end up with a positive 5,400 pounds, which means it's in the correct direction. All right, so therefore BY is 5,400 pounds, and it's acting upward because it's positive. Okay, now I can use my last equation of equilibrium. Sum forces in the Y equal to 0. 0 equals minus 300 plus AY minus 9,600 plus BY. right, which is 5,400, and then minus 600, and end up with a AY. Again, it's positive, so it stays on the right hand side, positive 5,100 pounds. So therefore, also in the correct direction, the direction we assumed, 5,100 pounds upward. Okay, so that's all old news, right? So we got AX 0, BY 5,400, AY 5,100. So that's what we need in order to establish equilibrium. Okay, now we want to draw the shear moment diagram. And remember, our reactions were, here was 5,100 pounds. Here we had 5,400 pounds. Okay, so again, shear calculation, start at x less than 0. Shear is non-existent or 0. At x equals 0, we have shear equals 0 minus 300 because it's going down, so a negative 300. So instantly we come down 300 pounds. Again, our units are pounds for shear. All right, uniform load is 0, so therefore W is 0, so therefore V slope is 0. So we know this is a horizontal line straight across. So we know at x equals 2 feet minus, V still equals negative 300. Now at x equals 2 feet exactly, we have V equals minus 300 plus 5,100, which equals a positive 4,800 pounds. Right, so it jumps up to 4,800 pounds. The change in the shear value is 5,100 pounds. Right, so now we're at 400 pounds at 2 feet, and at x equals 2 plus a smidgen, we also equal 4,800, but it starts to decline immediately, right? Our uniform load is 1,200 pounds per foot downward, so that means for every 1 foot down, for every 1 foot over, for every 1 foot over, we go down 1,200 pounds. Okay, so we know the total change, right? The total change in shear from A to B is going to equal the area under the loading, which is 1,200 pounds per foot, times 8, which we've seen that already, is 9,600. All right, so it's a change of 9,600. So at x equals 10 feet minus, we're going to have 4,800 minus 9,600. So that puts us at a negative 4,800 pounds, right? So when we get down to here, we're at 4,800, right? And we slope down like that. So where it crosses 0 is important, right? This is V of 0. So that location, we're going to be at, V equals 0 at 4,800 divided by 1,200, which equals 4 feet. All right, so this location here for maximum moment or 0 shear is 4 feet. Now, as we approach x equals 10, we have V equals a negative 4,800, but we have a reaction of 5,400. So we end up with a positive 600. So this shoots up to a positive 600. Okay. and at x equals 10 plus, still positive 600. Okay, again, W is 0. Remember here, W was 1200, so W is 0, so therefore V slope is 0. Okay, so it goes straight across. So at x equals 11 minus, V is still plus 600. At x equals 11, V is going to be plus 600 minus 600, which is 0. Okay, so this comes back down to 0. So there's the complete shear diagram. All right. So maybe I'll just see if I can move this all to the side. So that we can now do our moment calculations. And I probably should have enough room there. Okay. So now for moment, our unit of moment is going to be foot-pounds. Our unit is going to be foot-pounds. Okay. So remember the rules. The V magnitude equals the slope of the M diagram. So here we have a magnitude of minus 300. So between 0 feet to 2 feet, W, or I should say shear. All right. V is a negative 300 pounds. So therefore, slope of M diagram is 300 pounds per foot down. Okay. Well, it's really not pounds per foot. It's really foot pounds, isn't it? It's 300 pound feet down. Okay. So for every 1 foot we go to the right, we're down 300. So the change in moment from 0 to 2 feet is going to be the area of the shear diagram between 0 and 2, which is going to be 300. It's negative times 2, which is a negative 600. So this is 600 foot-pounds down. Okay. And notice that that is the area. Oops, that's this area here. The area, the positive area here, it means we're going to have a positive change in moment. Here we're going to have a negative change in moment. Here we're going to have a positive change in moment. Okay, so the area, so delta M from 2 feet to 6 feet is going to be 1/2 the base, which is 4 feet. All right, times the height, which is 4,800 pounds, which is 2 times 48, positive 9,600 foot-pounds. So M at 4 feet equals M at 2 feet plus the change in moment from 2 to 4. So minus 600 plus 9,600, we get 9,000, right, foot-pounds. So that peaks out at 9,000. It constantly changes magnitude, so it's a curved shear, constantly changes magnitude, so the moment is curved, and it maxes out at 9,000. Again, foot-pounds. Then the change in moment from 6 feet to 10 feet, right? 6 feet to 10 feet. Again, it's going to be 1/2 the base, 4 times the height, 4,800, which is 2 times 48, so plus 9,600 foot-pounds. Okay. I'm sorry, that's all negative, right? It's all negative change in moment. This is positive change in moment, positive change in moment, negative change in moment. So this should be negative. So M at 10 feet is going to be the moment at 6 feet plus the change in moment from 6 to 10, which is 9,000 minus 9,600, which puts us back to negative 600. And again, it constantly curves and comes down. Again, 600. Okay. Again, change in moment from 10 to 11 feet is going to be the change in moment is going to equal 600 times 1, which is a positive 600 foot-pounds. Right, so this area here, and that's a constant magnitude, so V is constant, so therefore M slope is constant. So M at 11 is going to be M at 10 plus the change in moment from 10 to 11, which is going to be minus 600 plus 600, 0 kip feet. And it's a constant magnitude, so it's a straight line. Okay. Slope of that line is 600 to 1. Slope of this line, 600 to 1. And this varies. Both of those vary. Okay. So again, that's the first review problem. And